Hello, it's Conra again, and I wanted to show you my slightly different method for solving a quadratic that has a leading coefficient that is other than 1. Oftentimes we learn how to factor these quadratics by trial and error. You'll see what is built into this method is a trial and error method. It's shorthanded and it's made very methodical so that you can do it much more quickly than just trying to write down all kinds of different problems, multiplying them to see if they work, and so on. Sometimes this method is written a little differently. Sometimes we will introduce letters like M and N and P and Q and show you how to do this. I'm going to bypass adding extra letters into the mix, and I'm going to just talk about spots that need to be filled in. So I'm going to illustrate those spots using shapes instead of using letters. That's what letters are in algebra. They're just ways of showing that there are spots that need to be filled in. Okay, so this is sometimes called the AC method. So our step one is that we are going to identify 4 different things. We need to be able to identify what A is. So A is the number in front of the x squared. Don't include x squared. B is going to be the number in front of x. And C is going to be the constant term. So notice that I want to include the sign in front of it as part of that number. The 4th number that I want to observe at this point is I'm going to figure out what AC is. So AC literally means A times C. It's just our shorthand notation. So once you find A and once you find C, then you can multiply them together and you can find this new number that we call AC. So we want to find another pair of numbers, maybe the same, maybe different, oftentimes different. We want 2 things to be true for that pair of numbers. We want, when we multiply that pair of numbers together, we want the answer to be AC. And when we take that same pair of numbers and add them together, we want the answer to be B. Now, here's the tricky part. We're going to use those 2 numbers once we find them, and we're going to take that middle term in our quadratic, and we're going to split that middle term into 2 pieces. So notice that the first term is the same, the last term's the same. We're just going to split the middle term into 2 pieces. We are then going to have something that has 4 terms in it, and we're then going to factor it by grouping. So for me, that was the hardest part to remember, was to remember to go ahead and factor by grouping. Once you're done with factoring by grouping, then you'll have the answer at the end. And what I may do is I may go ahead and add in a couple of extra steps, because when we factor by grouping, there are some things that we do in our head. They're so tedious to write that we very quickly stop writing them. But it's helpful sometimes to see them a couple of times again so that you can remember what you are doing in your head. Don't just skip the step. I want you to do the step in your head. So here's an example. I want to factor 3x squared plus 16x plus 5. So let's go ahead and figure out what A is. A is 3, and B is positive 16, and C is positive 5. And then AC is going to be 3 times 5, so AC is 15. So AC is 15, and B was 16. So I'm looking for a pair of numbers that multiplies to 15, and that same pair of numbers adds to 16. So I'm going to make an exhaustive list. I'm going to go ahead and start with 1. 1 goes into 15 times. So notice that we are trying to get AC. We want the 2 numbers to multiply to AC for this column. 2 does not go into 15. 3 goes into 15 5 times. And 4 does not go into 15. So we're back to 5. That means that my list is complete. However, I could try the opposite signs. So I could go through and keep going with my list, -1 and -15, -3 and -5. So then the next step would be to add those all together. So 1 plus 15 is 16, 3 plus 5 is 8, -1 plus -15 is -16, and -3 plus -5 is -8. So we are looking for B in this column, and in this case B was 16. So we're going to choose the pair of numbers that gave us a sum of 16. So double check. This is a tedious problem and you don't want to start working your problem out with the wrong numbers. So I find it's helpful to write those out and double check. 1 times 15 is 15. 1 plus 15 is 16. So step 3 is going to be to split that into 2 pieces. So we said that the two numbers were 1 and 15. And so now we want to factor by grouping. So I don't like parentheses because I see people make mistakes with parentheses. So I'd like to avoid that. I don't want to have to worry about using parentheses correctly. So I'm just going to use a little bracket to portion this off. So I am going to first of all look for the greatest common factor for 3x squared and x. So I look at the numerical coefficient, the number in front first, 3 and 1. They are relatively prime. They don't share any factors. So I could write a 1 down, but I'm not going to bother. And then I look at the variable part. I have an x squared and I have an x to the first. And the trick is that we are going to pick the smaller exponent. So we are going to choose to pull an x to the first out front. That is the greatest common factor for the first pair. So what we do, this is the step that we oftentimes skip. Whatever we wrote out front is going to be the number that we divide by inside. And so I guess we could keep going with this one. So if I take 3x squared and divide it by x, one way to think about it is subtracting exponents. So if I take 2 minus 1, I get 1. So I get 3x on the top and a 1 on the bottom. And same thing here, x divided by x is going to be 1. Okay, so I need to worry about my second pair. Whatever this sign is here in the middle is going to be this sign here. So this time I have a plus in front because my third term was a positive. And I look at 15x and 5. So first of all, I look at the numerical coefficient. 15 and 5, they share 5 as a factor. They're both divisible by 5, so I will pull 5 out front. I have an x in the third term, but I don't have an x in the fourth term, so I am not going to pull an x out. So I'm going to take 15x and divide that by 5. So again, I divide it by whatever came out front. So I'm dividing by the greatest common factor. And so 5 divided by 5. And so I'll carry that. That was plus 5. So 15x divided by 5 is 3x. And 5 divided by 5 is 1. So it is important to check these. We want to make sure that those match. If they don't match, then you go back and you start looking for an arithmetic error or an algebra error. We need them to match because we are going to use those as the greatest common factor. Because they each share that factor, we're going to pull that factor out front. So we had x times 3x plus 1 out in front of the plus sign. And we have 5 times 3x plus 1 after the plus sign. And because we pulled a 3x plus 1 out front, we are going to divide both of those by 3x plus 1. Okay, so we can look at that and we can see that a 3x plus 1 will cancel out of that numerator and denominator, and a 3x plus 1 will also cancel there. So on the outside we had 3x plus 1, and on the inside, before the plus sign we have an x, and after the plus sign we have a 5. You could go ahead and check that using multiplication to make sure that it does multiply back and turn into 3x squared plus 16x plus 5. Thanks for listening. I will talk to you later.